Okay, thank you, everybody. Yes, it's gone, Tere. Yes. So welcome to this last CREAF Talk before the Easter. So today we have with us Karine Princé. So she's a research associate at the Muséum National d'Histoire Naturelle in Paris. She describes herself as a conservation scientist and quantitative ecologist who is probably interested in applied biodiversity conservation. And she will give a talk today about the value of citizen science data to understand better biodiversity responses to global change, to assess the effectiveness of protection measures, and in some cases, even to support policy decision making. So I'll give the floor to you, Karine. Thank you very much.
Thank you. Thank you very much for the invitation, and thanks for all the people who are listening. So thanks for the presentation. And indeed, so my research focuses on studying the ecological risk. Sorry, maybe it's going to be removed after that. So my research focuses on studying the ecological responses. Yeah. Down, the global. Ah, sorry. Got it? No, sorry. Okay.
Is it better?
Yes.
No?
Sorry. Good start. So my research focuses on studying the ecological responses of biodiversity to global changes and local anthropogenic disturbances, as well as to conservation actions. And a particularity to my research is that it relies mostly on citizen science programs. So that's part of the what I'm going to present today. It's the research I have done this past decade and mostly relying on citizen science data. So citizen science, for maybe you're all aware of what it is, but it's the involvement of citizens from the non-scientific community in data collection. So in my case, it's relying on data collection on biodiversity. So it's a public participation, as I was saying. It allows to collect data over broad geographical scales and over long time periods, which result in extensive biodiversity datasets. And with that, we are able to answer different questions related to the impact of anthropogenic environmental changes or conservation actions at multiple spatial scales and temporal scales. So the outline of my presentation is going to be in 4 points. I'm going to present the contribution of citizen science data to increase our knowledge on biodiversity responses to global changes, to assess conservation actions and protection measures at different spatial scales, to support policy decision making. So this is ongoing work I'm doing for the European Commission on 2 different projects, and also citizen science as a way to foster pro-biodiversity behavior in volunteer contributing to those programs. So during one of my postdocs, a couple of years ago, I've been interested in studying the impact of climate change on North American wintering bird communities. So among all cold-adapted species, one quintessential group of organisms in which to study the impacts of climate change is indeed wintering birds, because they are highly sensitive to climate change, they are highly visible, so easy to survey and monitor, they are agile and mobile, and therefore might be expected to respond rapidly and readily to changes in their environment. Besides, one important fact about wintering birds and climate is that range boundaries of wintering birds are heavily constrained by minimum temperature. So studies have broad evidence that winter birds are responding to climate change. It was not new, especially through shift in distribution, but question remained at that time as whether and how these specific changes were resulting in community changes. So for this purpose, to answer that question, I mobilized data from 2 large citizen science programs in North America. So the first one was the Christmas Bird Count, a long-standing program of the National Audubon Society with over 100 years of citizen science involvement. So it is an early winter bird census where thousands of volunteers across the US, Canada, and many countries in the Western Hemisphere go out over a 24-hour period to count birds around Christmas. Count volunteers follow specified routes through a design of 15 miles, so 24 kilometer diameter cycle, to count every bird they could see and hear all the day. So just to give you an overview, in 2000, in 2022, for example, they had almost 80,000 participants, more than 2,500 road counts, and the number of birds reported were more than 40 million birds in this database, just for 1 year. And the second data set I used was the Project Feeder Watch data, which is a winter-long survey of birds that visit feeders at backyards, nature centers, community areas, and other localities in North America. So volunteers, they count birds for 2-day counts separated by a week, and this is repeated all during winter from November to April. And so they count more than 25,000 participants annually. And the number of observations submitted over the last 30 years were more than 30 million of observations. So using those data and relying on a functional index that corresponds to a measure of the species climatic niche, I was able to highlight that the structure of the communities of wintering birds has recently changed toward communities more and more composed of species adapted to warm temperatures. So this is what we are seeing here. Sorry, it's in French. So the community thermal index over the years, and we have an increase in this index showing that we have more and more warm adapted species within the communities. Then by mobilizing spatial temporal metrics of climate change, especially velocity metrics, I was able to show that these community changes were dynamic and spatially heterogeneous. So here you have a map showing the velocity of the community changes, community reshuffling, and we see that it's quite heterogeneous and we don't have the same speed of changes in the communities across the eastern United States. So this reorganization rate was calculated by the ratio between the temporal trends that I calculated right before and the spatial gradient of the community changes. So that was done here in the United States, and we've been able to show similar patterns in France with the French breeding bird survey with a student with whom I worked a couple of years after. And another result from that study was that by developing a method to evaluate the contribution of each species to the variation in community changes, I was able to show that smaller birds and those with southern species were contributed most to these community changes. So climate change and environmental changes more broadly have major consequences on biodiversity and ecological systems. So this is just one example, but they can have also an effect on the incidence of diseases and the emergence of pathogens. So you may all have seen that in the last years, the pandemic linked to the COVID-19 has brought the issue of zoonoses, infectious diseases, and that are transmitted between wild or domestic animals and humans back to the forefront, reminding us the extent to which human health, animal health, and ecosystem health are closely related. And a few years before the conceptualization of what we call now the One Health approach, I investigated the role of recent climate change in the resurgence of botulism epidemics in wild birds, which poses both a significant health risk to wildlife and to local human population in a lesser extent. So briefly, just to illustrate here, so this is a trend of botulism outbreaks in the region of the Great Lakes, and as you can see, so there are more now, but when I started the study, in the past decade, there are more and more outbreaks at that time. So it was a question to understand what were the reasons to that, and how could it be related to environmental changes and such question. So specifically, in this case, I studied the spatial synchrony of botulism toxin-related avian mortality events in the Great Lake regions. And for this purpose, I combined participatory science data, so from volunteers monitoring bird mortality events due to botulism through the monitoring of carcasses and sick birds. And I combined that with remote sensing data on different environmental characteristics of the Michigan Lake. And what I've been able to show is that there was a synchrony of botulism mortality events in water birds, so which corresponds to, by definition, coincident changes across geographically disjunct regions, and this is known as spatial synchrony. And this synchrony was mainly explained by fluctuation in local environment conditions. So as you can see here, so this is here we try to explain the variance in the spatial synchrony, considering only spatial proximity, only environmental condition, and combine spatial proximity and condition, and we show that environments play an important role in this spatial synchrony. Okay, so then I've been working also in few projects to assess conservation actions, effectiveness of protected areas, and for this purpose as well, I've been using and mobilizing citizen science data. So the first case I want to present is the assessment. So that was part of the huge assessment. I'm sorry, I don't know how to remove that, and you don't have the title, but it was within the assessment of the effectiveness of Natura 2000 in France. So there was a huge assessment ongoing. And here they were interested to understand the effectiveness of protected areas for non-targeted species, and that we referred also to a common biodiversity. So you may all know that, but Natura 2000 rely on two directives: the Birds Directive, so the special protection areas designated to protect endangered birds, and the Habitat Directive, with the special areas of conservation designated to protect threatened animals. And for this, assessing the effectiveness of Natura 2000, so I relied on the stock, Suivi temporel des oiseaux communs, the French breeding bird survey. So just to give you an overview, it was published for the 30 years anniversary of the French breeding bird survey 2 years ago. So this is a summary of the data the French breeding bird survey can bring to us. So it's almost 400 species that were observed since 2001. We had more than 2,000 observers since the beginning of the new program, so that's starting in 2001, and almost 3,000 of sites monitored across the country. So using this data, I analyzed bird population trends over the last 2 decades inside and outside Natura 2000. So those are the French release sites here in black, the sites that are within Natura 2000 areas, and I used also as a counterfactual sites outside, but closely related to a Natura 2000 area, and sites outside the Natura 2000. And I analyzed this while accounting for a set of other landscape description variables and the presence of other types of protected areas, because in France, we have sometimes overlap with Natura 2000 and other type of protected areas, national park, regional park, reserve, and stuff like that. So our main results showed that common bird species, which are initially not directly targeted by the European Birds and Habitats Directive, may have benefited of the protection and management measures from Natura 2000. So here you can see the illustration with the main result of the study, that the trend, so the temporal trend for overall population birds and then found number population were less declining, so still declining, but less declining inside Natura 2000, and even more pronounced, especially for farm and bird populations. So the recommendation here were that we needed more to improve the management plans, to expand potentially protected areas, and establish new ones if we wanted to increase the effort that was already started and have a better impact on bird biodiversity. At a more global scale, so I contributed to a work that was led by Victor Casalis, former PhD student. And in this case, it was to assess the effectiveness of protected areas at global scale. So in this study, we use a large citizen science biodiversity data set, so eBird. So I don't know if you're familiar with that. It's pretty huge now. It started in 2006. And we use this huge data set to quantify the extent to which protected areas in 8 tropical forests across the world. So 8 tropical forest biodiversity hotspots, sorry, I need to precise, are effective at retaining bird diversity. And in this case, we found a generally positive effect of protection on the diversity of bird species that are forest dependent, endemic to the hotspots, or threatened or near threatened, but not on the overall bird species richness. And in addition, we show that in most of the hotspots examined, this was driven by protected areas preventing for both forest loss and forest degradation. So results at that time supported calls that were made for increasing the extent and threatening the management efforts within protected areas to reduce global biodiversity loss. So an ongoing, two ongoing projects I'm doing right now are more to increase the interface between science and policy, and in the middle using citizen science data to try to bring additional scientific knowledge to support policy decision making. And the first project I wanted to present here is the work I'm doing to embedding the farmland bird index in CREAF modeling tool. So this is work I'm doing with a lot of colleagues from the GRC and discussing with some of the people in the room already. So just a little bit of context, in line with the targets for nature restoration and conservation indicated by the EU biodiversity and the farm to fork strategies for 2030, the Common Agricultural Policy has included in one of its key objectives the contribution to biodiversity protection, as well as the enhancement of ecosystem services and the preservation of habitats and landscapes. So the Common Agricultural Policy, it's quite huge, and in terms of modeling, it's not a black box, but it's a huge model. I won't detail here, but just to show you briefly, it's the objective of the CREAF model. So it relies on a huge model combining regional, CJ, global multi-community model, and the objective is to evaluate ex-ante impacts of the Common Agricultural Policy and trade-off policies on production, income, markets, trade, and the environment from global to regional scale. The only thing is that they use for now in their assessment a set of environmental indicators, but there were no biodiversity indicators properly. So that was where the European Commission made the request, trying to have this indicator that is a long-term indicator that is a consolidating indicator by the European Commission, the FBI, and trying to have it as part of the other environmental indicators to assess former CAP reform, policies, changes, and stuff like that. So the aim of the study I conducted were to find initially the relationships between changes in farmland bird population and changes in agricultural practices, to further embedding the FBI in the CAPRI model. And then, so after developing a modeling framework to forecast species abundance on the basis of the species abundance data from PECAMS and data on agricultural inputs that were provided by the GRC, the work consisted in computing the FBI and testing it with some scenarios provided by the GRC. So I'm going to detail just a little bit the methods, but not too much the models. I can answer a question a little bit further if you have some questions. So the spatial units we used were the NUTS2, because it's the spatial units that is provided with the CAPRI data. They are provided at the NUTS2 level. So I use these spatial units for the overall of the study. And we distinguished the 4 macroregions that are also considered by PECAMS to produce the bird indicators, the bird trends indicators. So the Central and East Europe region, North Europe, South Europe, and West Europe, that makes sense both ecologically and also in terms of agronomic perspectives. So as I said, I use the Pan-European Common Bird Monitoring Scheme. You may know this program here. So a major international citizen science project with long-term data on European bird populations. And so for this study, we used about 20 countries, a little bit more now because I'm doing an update of the modeling frameworks, and with data going up to from 1980, to 2013. So we selected the bird monitoring sites as follows. So we selected sites surveyed at least once between it's 1990 and 2013, and with at least 10 sites surveyed each year within NUTS2. It's to avoid a problem of convergence and a lack of power when doing the models, to be sure that we have enough sites per NUTS2 region when we are doing the modeling. And then, as for the selection of species, we selected the species from the farmland bird indicator, but we removed 6 of those for which are rare species and for which it was difficult to add estimation. And we used 33 farmland bird species to do our assessment. And then I aggregated all the data at the NUTS2 level by calculating the sum of species abundances per NUTS per year, meaning that I'm modeling a regional abundance per NUTS2 and per year. And to confront the data to agricultural data, so we use the time series that are provided by the GRC, by CAPRI, and we use output coefficient and also activity levels related to hectares and heads of livestock and other variables like that. So briefly, I used a set of variables that could represent the different agricultural systems at the regional level. So first, the crop shares. So I grouped the different cropping areas into categories that were considered to make sense in this case. And another set of variables related to energy content for food and feed. So this is based on crop yields, because we had a study previously that was making a link between such variables and bird community diversity. The fertilizer, thinking it could be interesting in this case. The livestock and crop intensity, so we use proxies. And I'm currently revising the variable I'm using here. The land use transitions and the utilized agricultural area. And finally, the land cover to characterize the main land cover within the NUTS2 region. So we end up with a selection of nuts that was both for CAPRI time series and breeding bird survey time series, and which are representing here in terms of the selection of the nuts. So we had 70 countries, a bit more now that I'm doing the updating. 150 nuts among the 179, and it's about 800,000 observations that I'm compiling in my dataset to make this assessment. So I won't detail too much the model. Don't hesitate to ask questions at the end if you want to know more. But what I did first is to run the statistical analysis to do the link between bird community abundances and agricultural practices. So I ran what we call a habitat model to estimate regional abundance as a function of the CAPRI variables and non-cover variables within each macroregion. So I did a model for each macroregion differently. So we have an example of a model here, and what could it be? And it differs per macro region. And the next steps of the work were to calibrate and make prediction to ensure that my models were robust and correct, and then compute the farmland bird indicator, so predicting the abundance based on the model I developed here, and then calculate the FBI. So this step is done then when I have data in the future, and this is relying on the data provided by the GRC with the scenario. So that's the next step I'm presenting. So after doing this first step of developing the modeling framework, they sent me a couple of scenarios. So a baseline scenario based on the projection from the medium-term outlook. So a baseline, sorry. The Common Agricultural Policy is fully implemented in 2020, and then the baseline scenario assumes that it remains the same until the simulation year. And then we have a couple of others. So the removal of voluntary coupled support scheme, increase of share of fallow land at regional level by 10%. So those are not exactly fitting the policy's expectation. They are trying to, how can I say that in English? To push the limit a little bit more in these scenarios to see how the FBI can behave. And those are not fake scenarios, but those are not exactly the scenarios they are developing because of confidentiality. And so all the 4 scenarios were compared to what I mentioned to be a baseline scenario. And based on that, I was able to then produce such results where we have a forecasting of the FBI under the different scenarios. So the result is not to be taken just by its own, but to be compared between scenarios to see the performance of the scenarios. And this is how it's going to be used then for the policy assessment and see whether or not there are scenarios that are better suited for all the set of environmental indicators. So this is at the European level, because then I could aggregate all my projection at the European level. And because I have predicted abundance at the NUTS2 level, I can also have the FBI at the NUTS2 level and within the macro region. So I'm able also to show the differences, the different response to the scenario within each macro region. So the GRC, déjà agree, they are more interested in the full European picture, but it's also interesting to be able to confront our results to what is used also in terms for PECAMs, for the indicator produced at the macro regional level, and to have those comparisons. And because as I was saying, because I'm producing my projection at the NUTS2 level, then we are also able to visualize that spatially at the European scale and to see the spatial variation of those scenarios. So, for example, here we have the no-cap scenarios and the combine and see the differences among the two, especially when you, in addition to that, I can also compare with the map the map that illustrates the changes in fallow land, in certain crop shares, and the changes in my different variables. So to see which one could affect the most of those changes. So this is still ongoing work because a couple of months ago, I received a new update of the time series from Capri, because so far it was going on only until 2013, meaning the cap before the one we had already finished. So now we have data up to 2018, and I can match that with my time series for the bird data, which were already going up to 2018. So I can update my modeling framework and redo all this work based on those longest time series. Plus, it will give the opportunity to add some of the countries. So here is the prediction. So we predicted everywhere. But I had some countries I could not include in my analysis because I had no data that could be matched, no bird data that could be matched with the Capri variables. So now we are almost able to have a full picture at the European Union level. So this is what I mean. And another addition to the perspective and the ongoing work I'm doing is that with the new set of the new time series I received, there were new variables that were included in this update of the time series related to the pesticides. So that's part also of the work I'm doing right now to test for the relevance of the new pesticides variables. So we have different aggregates of pesticides variable and see whether it has an impact or not, if it's relevant to model the abundance of birds in the case of the framework we developed here. Okay. So that was the first work that I'm doing right now for the European Commission. And I'm doing another one, but totally different in terms of habitats, because it's not on agricultural areas, but on urban ecosystems. So just to give you a bit of context, between 2019 and 2022, the European Commission promoted a number of initiatives to protect the environment and minimize the risk to climate, human health, and minimize risk also to biodiversity. So these initiatives have implication for the plan and the management of urban areas within the EU, which also should contribute to fulfill their objectives. And among the initiatives developed by the European Commission, there was the Biodiversity Project. And my work I'm going to present was part of this project. So Biodiversity Project is a European Parliament pilot project developed with the aim of enhancing the use of urban green infrastructures to enhance the condition of urban ecosystems, providing benefits for people and nature. So the work I'm going to present was just a little study case among this huge biodiversity project. There has been a report. I'm going to show you the reference and I can share it later if you want. So it was just initially a study case within this biodiversity project. So among all threats on biodiversity, biotic homogenization is a pervasive threat in the ongoing biodiversity crisis, and it's a threat that is major in urban ecosystems. So for those who are not totally aware of what is biotic homogenization, so it's the process by which the genetic, taxonomic, or functional similarities of regional biotas increase over time. So the taxonomic homogenization describes the increased similarity of species over space and time, and the functional homogenization is the convergence of ecological niches and functional roles among community members, so it's a species within the communities. So our interest here was to explore how urbanized areas has impact on the diversity of species and the structure of communities, and whether it could counterbalance this process of biotic homogenization. And for that, birds are pretty good indicators. So we relied again on bird data, which is most of my research rely on bird data. And so just to give you an overview of the work we've done here, so the objective was to explore the effect of urban characteristics on avian population and communities. So we relied on different datasets, a full set of ecosystem condition spatial indicators that were produced at the EU level through different initiative projects and by different units at the GRC, and the breeding bird survey data. So at the French level, so the stock I presented earlier. Then I run quite a few statistical analyses to try to explore or determine which urban ecosystems could provide support to avian population and communities. So in terms of data, there has been, so I think most of the variables are described in this report. So sorry, it's not very clear, but it's the report mapping and assessment of ecosystem and their services, an EU ecosystem assessment. I think the main author is Joachim Maes. So we used those variables of a wide standardized set of indicators developed to monitor urban ecosystem conditions. So it goes from the settlement density, greenness in urban areas, everything related to the state of the development in the city, but also the trends how the cities became more and more dense, more green, less green, etc. And we combined that with the French Building Bird Survey that I already presented, so I won't do that here. And we worked at the scale of the functional urban areas. So initially we choose this spatial unit because it's a spatial unit that is used in administrative decision also at the EU level. So it was making sense in that way. So we selected almost half of the functional urban areas in France. And we worked with 170 common bird species to run this analysis. And we restricted our analysis to 2015 to 2012, 2019, sorry. So it's really a short-term analysis because we have no data, environmental data on trends. So it's only the data were provided between 2015 and 2018 for urban characteristics. So briefly, we use so first I did a multicollinearity analysis because we had a huge set of variables, almost 30 I think that were initially selected. We had hypotheses behind each variable. Some of them could be very collinear, very correlated. So the idea first was to identify multicollinearity among the environmental variables and reduce the set of covariates at both the functional urban area level and the site level. So I considered the two spatial scale, thinking that bird abundance and community diversity could be influenced by condition at the local level, but also at the functional urban level, because it makes sense in terms of policy decisions. And then I did some regression analysis to analyze bird abundance of the overall population and habitat specialists and generalists, and also certain bird diversity metrics related to the taxonomic and functional diversity. So the key findings for this study were first that urban dense settlements face biotic homogenization in urban ecosystems. And as you can see here with this illustration, so community specialization index, we can see that the more the urban density increase and the more the less specialists we have, the more generalists we have in these ecosystems. Another key findings was related to what was initially the focus of the study, the urban green infrastructures, which have the potential to reduce biotic homogenization. Especially, as you can see here, it allows to increase species richness and some functional diversity related here to the trophic level of the communities. And also, it allows to improve, increase the abundance of the majority of common bird species. Similarly to green infrastructures, blue infrastructures in functional urban area, even at low or intermediate level, as you can see here, can increase bird taxonomic and functional diversity and the overall bird abundance. And another interesting finding of this study was that sustainable land use practices, both for agriculture and forestry, could help support richer and more diverse bird communities, as we can see here with the increase of the overall abundance, with the increase in the share of low intensity agriculture within the functional urban area. And we have the kind of a similar result with increase in the different diversity metrics, especially at high rates, high increase of the share of forest close to nature. It's another component of the sustainable land use practices related to forestry. So the next step for this, it's a work I'm starting now, is to implement the same methodology, or at least similar, at the European level and within the EU local urban areas. And this time we're going to use the PECAMS data to model the response, to investigate the links between bird diversity and the different urban characteristics at the European level. So all along this different presentation, I have given you an example on how citizen science can help producing scientific knowledge with the participation of non-scientific and non-professional stakeholders. But citizen science, due to its variety of forms, have also a variety of objectives, among which to produce knowledge, not only scientific knowledge, also for the participants, and increasing the empowerment of the stakeholders. So in a different project, we've been interested in such question, relying on citizen science data in France, and the question about, is it a way to foster pro-biodiversity behavior? So research studies on pro-environmental behavior have shown that the knowledge deficit model, which consists in simply providing knowledge on detrimental effect of a practice or benefits from another one, is not enough to change behavior. Environmental education, however, seems promising in that sense. And through both formal and informal learning activities, outdoor observations, encouraging messages or sustainability objectives, it can potentially help with the environmental education. The questions that comes then is, does this work for pro-biodiversity behavior in the context of citizen science biodiversity monitoring program? So for this purpose, we looked at this question through the Observatoire de la Biodiversité des Jardins. It's the Butterfly Observatory in France, and exploring whether the participation in such a project could change the behaviors in garden owners. So we explored this question through the Garden Butterfly Observatory, and we also considered the garden characteristics and use of pesticides that are indicated with the observation from the observers. So in this program, observers, they provide information about those practices in their gardens. We thus focused on three components: the nectar offer, the naturalness, and the pesticides. The observation data consists in monthly monitoring counts, and we considered gardens surveyed over an 8-year period. We used years of participation, so the number of years, and allocated time as explanatory variables. So to analyze such relationships, we accounted for garden area and also the proportion of urban area at the city level. And what we found is that the nectar offer significantly increased with the number of years of participation to this French butterfly survey, with a plateau after about 5 years, and we found similar patterns with the naturalness. And quite interestingly, also, we found that the use of pesticides did not change for a non-urban area, but it changed in urban area for observers living in urban area, and it changed as a decrease in the pesticides use. So it seems that yes, it can foster pro-biodiversity behavior. So it was a pretty exciting findings using this data and those information that were collected as part of the observation program. And this reflects a shift toward more biodiversity-friendly garden practices, in this case, as citizen science scientists participate to a national garden butterfly survey. And this is in line with feedbacks we could get from observers in recent survey, where they have been asked what output they were getting from participating to this program. So we got a lot of feedback saying that they would have more knowledge, they would have understand more the ecological processes, and it indeed implies some changes in their behavior because they were more aware of what was the nature surrounding them, and also with the newsletter, all the information transmitted by the coordinators of the program, they're also aware of what could be good practices and practices that are not necessarily favorable for the biodiversity in their garden. So all these results were quite interesting. So given recent findings that were found by colleagues, where they found that an increase in naturalness, nectar offer, and decrease in use of pesticides tend to be correlated with an increase in diversity and abundance of butterflies. So I think I did not put the reference here, but it was a paper from Benoît Fontaine and Audrey Murati. Okay, and with that, I would like to thank you for your attention. I will be happy to answer any question if you have some. And same for the people online.